Hello, my dear friends. Welcome back to my channel. Today, I am going to discuss a very important topic of implantology, that is parts of a dental implant. What is the structure of a dental implant? It consists of abutment, screw, and a crown. Okay. What is the comparison of tooth and implant supported structures? In tooth, the connection is in cementum, bone, and periodontium. Whereas in implant, it is osseointegration and bone functional ankylosis ligament. Then junctional epithelium contains hemidesmosomes and basal lamina, that is lamina lucida and lamina densa zones. Then in implant, lamina densa and sublamina lucida zones are there. Then connective tissue in tooth, there are of 13 groups. It's perpendicular to tooth surfaces, less collagen and more fibroblast. But in implant, only two groups are there, parallel and circular fibers. And no attachment to the implant surface and bone. And there is more collagen and less fibroblast. What is the biological width of a tooth? That is, it is about 2.04 to 2.91 mm. And in implant, it is 3.08 mm. What is its vascularity? It is greater in tooth, that is supraperiosteal and periodontal ligament. In implant, it is less vascularity and it's periosteal. What is probing depth? 3 mm in health in tooth and in implant 2.5 to 5 mm depending on the soft tissue depth. Then bleeding on probing is more reliable in tooth and it is less reliable in implant. Here, the physiologic movement of a healing tooth has been measured as 0.028 mm or 28 microns in the apical direction and up to 108 microns in the horizontal direction. So that is about the physiologic movement of a healing tooth. Okay. This is the biologic width for a natural tooth, which is approximately 1 mm of connective tissue above the bone and 1 mm of epithelial attachment between the sulcus and the connective tissue. Okay. This is the comparison of natural tooth and root and dental implant and crown. This is the crown. Okay. And here it is gum tissue. Here is also gum tissue. This is the tooth root, but in the implant case, it is abutment and this is the implant. This is the bone. Okay. And this is the bone. And this is the picture showing the biological width of a natural tooth. It has a connective tissue zone. Okay. It inserts into the cementum of the tooth. This is the periodontal probe which penetrates the sulcus and junctional epithelial attachment. And here the implant, it has no connective tissue fibers in the connective tissue zone that insert into the implant. Peri-implant probe penetrates the sulcus, junctional epithelial attachment and most of the connective tissue zone. Here the sulcus and the epithelial attachment above the implant body does not have a true connection to the implant. This is a comparison of soft and hard tissues approximating the natural tooth versus a dental implant. This is the enamel. Here, this is the sulcular or clavicular epithelium. This is a tooth, okay, and this is an implant. So here it is the titanium implant. So this is the enamel, okay. Then this is the connective tissue. This is junctional epithelium, and this is the soft tissue attaches to the tooth. Here it is cementum, then periodontal ligament. This is the bone. And this is the junctional epithelium, this is the connective tissue, and here it is the implant, titanium implant. Okay, and this is the bone. And there are three primary types of root form body endostyle implants based on design. They are cylinder, screw, combination. So these are the three major types of root form body implants. So these are the cylindrical root form implants. It depends on a coating or a surface condition to provide microscopic retention to the bone. Most often it is either coated with a rough material, that is hydroxyapatite, titanium plasma spray, or a macro retentive design, that is sintered bones. And these implants are usually pushed or tapped into prepared bone site. And then they can be parallel walled cylinder or a tapered implant. Coming to the screw type, they are threaded into a slightly smaller prepared bone site and have the macroscopic retentive elements for a thread or thread for initial bone fixation. And they may be machined, textured or cotton. Then coming to the combination type, it has macroscopic features from both the cylinder and screw root forms. Okay. And based on the surgical approaches, there are three different approaches for two-piece implant systems. They are two-stage, healing submerged, then uncovery surgery. One-stage, implant with permucosal healing, no uncovery surgery, and immediate restoration, that is restoration placed at the time of surgical placement. So there are three different surgical procedures. One-stage, two-stage, and immediate restoration or immediate load. And the implant body can be divided into a crus module, body, and an apex. Crus module, or it is known as cervical geometry. Okay. What is a crus module? It is that portion of an implant body designed to retain the prosthetic component in one-piece or two-piece implant system. And it is primarily designed for either surgical ease of prosthetic loading to the implant bone interface. Okay. So implant body is primarily designed for either surgical ease or prosthetic loading to the implant bone interface. So implant body is the portion of the dental implant which is designed to be placed into the bone to anchor the prosthetic components. It has crus module, body and apex. Okay. And the main components are implant fixture, abutment and the superstructure. The most common outer thread diameter is 3.75 mm. Thread depth is 0.38 mm and thread pitch is 0.6 mm. This is the thread pitch, that is the distance between the threads. Okay, and the thread depth is the distance between the most outside thread and the most inside thread. And according to the thread shape, they are of three types: V-shaped, square and buttress. This is the V-shaped thread, this is the square-shaped thread and this is the buttress-shaped thread. Okay. This is the one-stage implant body design. It has an extended crus module which extends through the tissue at the initial surgery. A separate permucosal element is not required with this design. Here the one-stage implant body design used with a one-stage surgical approach in which soft tissue around the implant heals while the bone is healed. Here the second stage surgery is eliminated. When an implant is placed with the abutment connection at the crest of the ridge, after the permucosal abutment is connected, the bone is usually lost to the first thread, especially when the crus module is machined or smooth, that is in the right side. Okay. So when the crus module is smooth or polished metal, it is often called a cervical column. And these are the various hex connections, internal hex connection and external hex connection, and also there is Mohs taper is also there. Okay. So implant body, here this is the implant body which is usually separate from the implant abutment and most often connected together with abutment screw. So this is the internal hex connection and this is the external hex implants. Okay. And finally we move to implant components. It is different for each company. Okay. This is the prosthesis screw. Here it is the coping and these are the analogs. This is for implant body and this is for abutment. And these are transfer copings or abutment or implant body. So these are for indirect technique, and this is for direct technique. And this is the hygiene screw. And these are the abutments for screw retention, cement retention, and for attachment. This is the second stage permucosal extension or healing abutment. This is the first stage cover screw, and this is the implant body. So these are the various implant components. Here, this is the permucosal extension which attaches to the implant body and allows the soft tissue to heal and mature around the future implant abutment. And they may be same size as this crest module of the implant body or slightly larger and help to develop the emergence contour of the implant. So intraoral view of 8 second stage permucosal extensions that were inserted into the implant bodies. Here, this is the abutment for screw retention. This is used for screw retained bar or fixed prosthesis. These are for cement retention. It may be one piece or two piece. Then these are the abutments for attachment used for removable prosthesis that are implant retained. And these may be used for complete dentures and partial dentures. So based on the restoration, they are of indirect transfer and direct transfers. So indirect transfer, it is inserted into the implant body or abutment for screw retention, and a closed ray impression is made. The impression is removed and transfers are connected to analog and reinserted into the impression. And direct impression transfer uses the open tray technique to make the impression. And direct transfer coping screw must be unthreaded before the impression is removed from the mouth. Okay, so this is the ball top screw, straight abutment for cement hex. This is for closed tray technique. And here direct transfer coping screw, direct transfer coping hex. This is open tray technique. And for multiple unit restoration, this is a ball top screw. This is the straight abutment for cement hexed. Indirect impression coping non-hexed. One piece abutment for cement non-hexed. This is for closed tray technique. And this is a direct transfer coping screw. This hex, and then this is the open tray technique. And this is the color coded scheme. That is, it's the yellow color, that is 3.5 mm, green 4 mm, blue 5 mm, and violet 6 mm. These are the implant analogs. This is the O-ring abutment, and this is the O-ring abutment analog. And that's all for today's lecture. Please do like, share, and subscribe my channel for more videos. And thanks for watching.